Greetings from TaiyangNews. I am Shravan Chunduri, Head of Technology at TaiyangNews. The team of TaiyangNews is currently on the floors of Intersolar Europe, the largest solar conference of the planet. Right now, I am at the booth of AE Solar, and I am with my dear old friend Hanifi from AE Solar. And Hamid, when I met you for the first time, I think 3 or 4 years ago at the Intersolar, you had a very cool display of the concept of shading resistant modules, which you made a very nice display, and you explained me, how great it was. But just now, I also heard you got a new project with Fraunhofer CSP, and this is something really next generation. So please fill the gap.
Yeah, sure. Thank you very much, Shravan, for coming here, and very appreciate the TaiyangNews efforts. Yes, as you mentioned, several years ago we developed one of the first shade-resistant modules in PV industry, and this module had integrated bypass diodes per every single solar cell. We launched it in 2018 to the market, and we were selling it until past few years. But according to the technology development and the restrictions in the old technologies, we had to make a refreshment on the design of the module, and that was the motivation of making a segment PV project, which is a national level project funded by Federal Ministry of Economics and Climate Action in Germany, and with collaboration with Fraunhofer Center for Silicon Photovoltaics, or CSP. We together started the segment PV project, where we developed a new generation of shade-resistant PV modules. And this module has many advantages compared to the previous generation, but it was not enough just to develop it. We needed a partner to test it, and we prove everything to ensure the durability. And that was the motivation. So we started the project 2 years ago, and we already have the concepts, and we already have the prototypes that they are being tested at Fraunhofer site.
So you just touched the word advantages, but can you elaborate more on what are the real advantages in the field?
Mm-hmm. Yes, so firstly about the advantages of the module compared to the previous generation, I can elaborate a little bit, and then I can say what is actually the benefit when it comes to the field. So generally PV modules are very sensitive to shading, so even 5% shading of the module area can lead to a total shutdown of the PV module. So there are roofs that have many different elements, including different building infrastructures or chimneys, antennas, or the cast of the shadow from the other neighboring trees or other buildings, even on the roof of the one house. So it's going to significantly influence the energy yield performance and also the reliability of the modules on the roof. So this was the motivation to bring generally these modules to the market, because with this module, it doesn't matter what is the efficiency. When the module is shaded, it produces nothing. And we should understand that the customer always buy the PV module as a watt peak or efficiency of the module, but what they really need is energy. They need kilowatt hours. And this module, even it's shaded, can generate electricity. Compared to the old generation, we saw that, previously we had one bypass diode per every single solar cell, but after the research and development that we did, we find out with the new generations and having half-cut solar cells, we really don't need this much of bypass diodes. We didn't want to implement 120 bypass diodes in the module, so we started to come up with other clever ideas, and we started to segment the module. By segmenting the module, we could have a better control on shade tolerancy of the PV module, and this could help us to bring more energy yields per area from the rooftop. And this was the main motivation that we came from the old generation to the new generation, and the new generation benefits from less bypass diodes integrated in the module. And furthermore, the bypass diodes don't get hot when they are on operation. So basically, not only energy yield here is considered for development of the module, but also reliability and durability of the module.
Okay, so I don't know how much you would like to be open here. You said segmented. Of course, you want to protect your IP. You don't want everyone to copy your efforts and research. But can you go any more into the details of segmentation of the cells? Keeping everything, your IP protected and your secrets undercover. But can you go some more into the details?
Sure. So in general, by segmenting the PV module, we consider a group of solar cells being protected by a bypass diode. So this brought a lot of challenges for us to implement the bypass diodes inside the laminate, meanwhile protecting enough solar cells. So we developed a simulation model. We started to simulate different module designs by grouping a small number of solar cells. And then we find out there are some scenarios that we can generate significantly more energy, but meanwhile we have less reliability risks. And this was the motivation, so we started to play with the designs and came up to some very interesting designs, few of them, where we tested all of them at Fraunhofer CSP to make sure of real-life performance and also indoor measurement results, as well as the reliability of the module. So the main trick here is to make a small group of solar cell by reconfiguring the module design and making a very clever circuit.
And then can you say something on the cells part that are integrated into the modules?
Sure. So we had many different possibilities to choose the best solar cells. So what we did, we started to test them. So we bought several types of solar cells, including heterojunction, TOPCon, even we tested PERC and back contact. So we wanted to see where is our sweet spot by considering the performance, reliability, and of course availability of the materials. And that was the reason we started to testing. So we did indoor measurement tests because we wanted to see the behavior of the solar cells when they are in reverse bias. This means that when they are shaded, the solar cells become a consumer instead of being a generator. Yeah. So we wanted to see which one has the lower risk in terms of heat losses and in terms of performance. So we tested all solar cells and including all other factors, including the availability of the materials and the best setup that we have from durability, performance, and supply chain. We decided to go with TOPCon solar cells.
So it's TOPCon?
It is TOP.
Okay. So, Hamid, having shade resistant module, of course, I saw at your booth for the first time, but then later on several companies have also started adapting this technology. And I'm not sure what's really behind their technology, but from a broader perspective, what is the difference between your technology and several other shade-resistant module technologies right now available in the market?
Thank you very much for this question. So basically, most of modules which is being sold in the market at the moment are back contact solar cells. Right. Of course, back contact solar cell has some advantage of a lower reverse breakdown voltage, which I mentioned also in the previous question. And this means that when the solar cell goes into the reverse mode, it breaks faster. So when it breaks faster, it has one advantage that will have lower losses. But if it doesn't break at all, so you have even higher advantage. So it was not something that we want to neglect. So we even tested those setups and those solar cells to see actually in the sense of performance which choice is going to be better. So we tested also at Fraunhofer CSP with indoor measurement and also reliability test. And the results shows that with the TOPCon cells and the design that we have on the module, we're going to have significantly better results. And in some shading scenarios, because we started to have like different shading scenarios, to have a feeling of real life shading situations. And we saw that in many of them, for the worst case, we had somewhere around 25%, and for the best case, we had somewhere around 80% better energy performance and general module performance compared to existing modules in the market.
So Hamid, what is the economic aspect of this shade resistant technology, over the module's lifetime, and the economic calculations of this technology and approach?
Thank you very much, Shravan. That's also a great question. Basically, when we are developing a module, we have to always think about the economic aspects of it. So this module, of course, have higher components in the module, and there was a higher investment in sense of research and development to develop this module. But a very interesting point of this module is coming back to the customer side. So as I mentioned in the beginning, when the module is shaded and it's a standard PV module, you lose basically all power and energy. So this is not what you want. What you want is to generate energy in any circumstances. This is what the new PV shade resistant module of AE Solar is is addressing. So with this module, you generate energy even when the module is shaded, because compared to power optimizers, when there is a shading, the power optimizers only try to balance the current to avoid any mismatch. But a string which is shaded has already lost the energy. Here, it's not the case. So we don't lose the whole energy of the module. And second of all, according to a study from Zurich University that they tested even our old generation module, they came to a conclusion that by having such modules, you actually don't need a power optimizer. So basically, the module is going to be slightly more expensive than a standard PV module, but meanwhile, in a system level, you don't need a power optimizer. This means you have a system which is going to have almost the same system costs, but on the other hand, it produces energy significantly more than even a system with power optimizer. And this brings higher energy yield production, and meanwhile leads to a lower levelized cost of electricity in the lifetime of the system. So that was the motivation to develop this module. So you reduce the system components, although you're adding a little bit components to the module, and meanwhile you can reach to a better levelized cost of electricity and have a less complexity in system level. So that was the whole idea of going for it from the economical aspect, and hopefully we see this module very soon in the market. We are expecting to have the launch dates next year, and the product is going to be offered to the market under a marketing name of Shade Star.
Shade Star?
Yes.
Okay, very nice. Okay, thanks, Amit. And then, I also have few questions directly to your research partner, who is Fraunhofer CSP. Bengt, I have few questions for you.
Okay, let's do it.
So, Bengt, what kind of test you did at your institute?
So to support, let's say, this kind of development, we looked from different angles in terms of the components of the PV module itself. So we started basically from the solar cell, asking ourselves, okay, what is the solar cell which is the best for creating a shade-resistant PV module that is also long-lasting? And that basically also ties directly into, let's say, the configuration of the electric circuitry itself, including the bypass diodes. And there we also had different opinions about which diode is good. Let's say also some challenges in terms of geometry, because typically most diodes in the past were round and big, but something like that, it's not going to work in such a product. So we also had to look into, let's say, the dimensions, flat ones, and on top of that, there are some challenges in terms of manufacturing, So just write the circuitry down, it's one thing, but in the end it should be a product which is working also in mass scale. So the diode needs also to have some properties for manufacturing. And that's, I think, what we also looked at from the different angles, diode characteristics, but also manufacturability, that in the end it will also be something what you can do.
So can you also emphasize a little bit on AE Solar's product, from the shade resistance perspective? So what are the most important features that you really think are really interesting, and how AE Solar products are fitting into your tests?
So I think we have to go one stage back, basically, to ask ourselves, why do we need, first of all, a shade-resistant module? Yeah?
Right.
So when you would ask me the same question, I would say 5 years ago, I would say, the market is not very big. But now, when you look at what Energiewende, let's say in Europe, Germany especially, it means is we add more and more PV into locations where you have built-in shades. Yeah? In the old days, PV was expensive. So shade you avoid it as much as possible because you lose power. Nowadays, PV module is commodity and you take as much space as you can. And then in the end, that also poses some risks in terms of quality and long-term reliability of the product. And that's why shade resistance modules also in the future will be of importance. And it's not just a no-brainer, You need also to think in the details to make it work.
Right.
And let's say the original one from AE Solar was pretty cool, 1 bypass diode per cell. This is the ultimate thing you can do, but you can also imagine it was back in full cell with 60 cells. Now we go 120 cells, so doubling the effort. So it's impossible to do that. So we sat back and thought, okay, what is a good trade-off between complexity and improvement on energy yield, because that's what the customer wants, while shading the module or accepting a certain shade percentage on the module. And that's where we looked at different configurations, and I think we came up with some good solutions.
So, of course, this is nice, the idea of shade resistance, but, you are basically also changing a little bit of the BOM. And then when, you are making it more robust probably, but then this also puts up the next question: how is the reliability? Anything you change in a module, you have to check the reliability. So I would like to also have your feedback on the reliability with this particular shade resistant module from AE Solar.
So thank you for the question, because reliability is, or durability of the product, so it's built in, and you have to think about, okay, what are the use cases, and let's say also the emission profiles of each module in a shade scenario. So obviously it needs to be as good as a standard product. So in terms of reliability testing, let's say we use a standard cell interconnection process. So with that, it's not better, not worse than any other module, which is good. So we have a good foundation to go beyond that. And while changing the electric circuitry, on the one hand side, you can argue you add a little bit of complexity, but you add a lot of redundancy in terms of, while shading, you lower temperatures, you lower the risk of material failures, and with that you make it more reliable. And that was basically the thinking about, let's say, this segmentation also of to make it smaller, not 20 cells or 24 cells. I also saw some products with 28 cells. Worst case scenario you can do. And if you lower that, the risk of local heating significantly is reduced, while expecting in the application regular shading. And that's also something the community needs to learn, that we go from a shade, which is a faulty situation, to a daily accepted situation. And that's a big step forward. Also, let's say no standard is covering that. So we do also here some special reliability testing, that we do this shading scenario repeated over and over again, just to understand we expect this as a mission profile, partial shading, daily basis. And that is something we also have to look at reliability to make proof that the product will also survive in such an application for longer than the others.
Okay. Thank you, Ben. Thank you.
Thank you for the interview.